Hello, this is Module 8 of Mechanics of Materials Part 1. Today's learning outcome is to define and discuss something which we're going to call normal strain. And so again, here's that axial test that I showed before of a specimen being stretched by an axial force. The length becomes longer. It's some L plus delta. And so we talk about strain as being the elongation per unit length. And it's given the symbol epsilon, and so it's that delta, that stretch, over the length. And it's dimensionless. We often talk about it as being millimeters per millimeter, or maybe inches per inch in the English unit system. But it's actually dimensionless because the millimeters per millimeter cancels out. The sign convention, again, a positive tension force causes a positive elongation. And a negative or a compressive force causes a shortening, and that's a negative strain. And so that's our sign convention. And here we go again. Similar to stresses now, we talk about normal strain or engineering strain. That's what we use in most problems that we're going to solve. It's based on the initial length of our specimen. The specimen will get slightly larger. For most materials, it's quite a small amount. And so if we were to use the actual length as it stretches out, that would be true strain, and therefore the strain would be a little bit smaller because the length would be larger. And so now we have the basic concepts of stress and strain fundamental to the understanding of mechanics of materials. I've got another worksheet for you. We're going to take another flat steel alloy bar. It's got an initial length of 900 millimeters. We're going to subject it to a tensile load, and we're going to say that the bar elongates by 0.5 millimeters, and I want you to determine the nominal or engineering axial strain in the bar. And again, I've included the solution in the worksheet, and when you finish it, you'll be all set, and I'll see you next time.